Going to be talking about PFAS. So a brief outline. So we're going to talk about contaminant information, sampling data that we've gathered so far. We're going to talk about the rule itself, so the National Primary Drinking Water Regulation. We're going to talk about the compliance timeline, and then some brief treatment options. To start off, what is PFAS? So it's a per and polyfluoroalkyl substances. PFAS are a category of manufactured chemicals that have been in the widespread use since the 1940s. PFAS generally break down extremely slowly in the environment. They're highly persistent. For example, half-life of a long-chain PFAS, such as PFOS, in the human body, the half-life is upwards of 5 years. And it's an emergent contaminant. A little bit more about it. So it's a synthetic chemical. So when we say it's synthetic, we're saying that it was man-made in a lab. It's not naturally occurring in the environment. So it's a synthetic chemical with chains of carbon atoms surrounded by fluorine. On the left there, you can see that there's two of the most common PFAS, PFOA and PFOS. Those are just so you can see what the chains look like. Those are the two most common, but there are thousands of different PFAS compounds. They can be single molecules or complex polymers. They can be found in the air, soil, and water, and so there's potential for exposure throughout the environment, not just in drinking water. PFAS is used widely in commercial and consumer products, and a acronym I like to use to kind of describe PFAS is PBT. So it's persistent in that it is slow to break down in the environment. That's how it's what commonly referred to as a forever chemical. It's bioaccumulative, which means that it builds up in the body of livestock and wildlife, soils, and waters, rather than just passing through or being eliminated by natural processes. And it can be toxic. Existing data indicates that some PFAS are toxic at extremely low levels. To put that in perspective, when we're talking about the rule, we're going to talk about it in parts per trillion, while other contaminants you're familiar with, like arsenic and fluoride and nitrate, those are regulated in parts per million. So just a few common PFAS sources. So things like nonstick cookware, stain-resistant products, firefighting foams, pesticides, fast food packaging, electronic manufacturing, some common uses. PFAS pathways. So this is an infographic I like that kind of shows how it can go to human exposure. So it starts all with the industry, and then it can go through a direct link to human exposure through consumer products. And those consumer products can also go to waste and then eventually enter the environment and then go to human exposure. Another link is straight from industry. It can go straight to the environment and human exposure, or to waste and then environment and then to human exposure. And then another big one is aqueous firefighting foams. Those are seen around airports and military facilities. But that's another PFAS contaminant. It can go to waste and eventually the environment, and then to human exposure, just into the environment and then human exposure. So some potential exposures, so working in occupations such as firefighting or chemical manufacturing, drinking water contaminated with PFAS, eating certain foods that may contain PFAS, such as fish, swallowing contaminated soil, breathing air containing PFAS, and then using products made with PFAS or PFAS packaging. Just some health effects. So with PFAS, we've seen some reproductive effects, developmental effects, or delays in children, increased risk of some cancers, reduced ability of the body's immune system, interference with body's natural hormones, and then increased cholesterol levels and risk of obesity. Now we're going to talk about some PFAS sampling that we've done in Texas. So an overview of that, the two main programs are UCMR, Unregulated Contaminant Monitoring Rule, done by the EPA, and then that's been occurred in, PFAS has been included in two of those, so it was included in the third Unregulated Contaminant Monitoring Rule, as well as the fifth Unregulated Contaminant Monitoring Rule. We'll talk about those in the next slide, but also PFAS occurrence monitoring, contaminants of emergent concern has occurred, and that's TCQ sampling. So for UCMR sampling, again, it was in UCMR 3. That was from 2013 to 2015 is when that sampling was done. It contained 6 PFAS chemicals. A majority of those are ones that are being regulated now. So they were PFOS, PFOA, PFNA, PFHXS, PFHPA, and PFBS. So all those except for the PFHPA are in the rule currently. So the 6 were monitored. The criteria for the sampling was all public water systems with a population greater than 10,000 were included in that sampling. And then 800 public water systems with a population of less than 10,000 were selected. And that was 800 from the whole US. And then UCMR 5, which is currently ongoing, 29 PFAS chemicals are being sampled there. The criteria for the water system selections for that one was all PWS with a population of greater than 3,300, and then 800 small PWS with a population less than 3,300 were selected, and again, 800 from the whole US. So just wanted to give you a data breakdown of the UCMR 5 data so far. I believe this is data that was released in January. So in total, 3,151 samples were collected. Of those, 884 had a detect of one of the 29 PFAS. And then of that 884, 454 had a detection of one of the regulated PFAS, which are PFOA, PFOS, PFNA, PFHXS, PFBS, and HFPODA, or genetics chemicals. So 454 were had a detect of one of the regulated, and then from that, 112 exceeded the MCL or the hazards index. Just wanted to go over PWS response required from UCMR 5. So if selected for UCMR 5 sampling, the system is the number of samples required by the EPA depends on the size of the system. The system would then collect the samples and then send to an EPA-approved lab. That lab would then post to SDWARS, and you can find the data results using the National Contaminant Occurrence Database. If unregulated contaminants are found through that UCMR 5, then they would have to be reported in the CCR. For the TCQ sampling side of things, if selected for TCQ sampling, you would be contacted by our contract samplers, and they would work with you to pick a date to sample. And these are the same samplers that are conducting your chemical samples currently. The samples would be collected, and then they would be sent to LCRA for analysis. And then once TCQ receives these results, we will send a letter to the water system letting them know if there were no detections. It'll just be a brief statement stating that. If there were detections, we would include a result table in that letter. But always you could reach out to us to get the full lab report. So I just wanted to go over the TCQ occurrence monitoring. As you can see in 2022, it's more widespread over the state. And that's because with those we were pinpointing areas where we thought detections would be more likely. So those were more targeted sampling sites that were chosen. For 2023, that sampling was just, you can see we picked, a county, we picked, Travis County, then sampled from these surrounding counties. And that was just any system that wasn't included in UCMR 5. So all the TCQ sampling is any system that wasn't included in UCMR 5. And for 2024, we're just doing a lot of resampling from 2023 to let the systems meet the initial monitoring requirements that we'll talk about in a little bit. So a breakdown of the TCQ data. So for 2022, 553 samples were collected. Of those, 231 had a detect of one of the 29 PFAS. And then of those 231, 125 had a detect of one of the regulated PFAS, and then from those 32 exceeded the MCL, the hazardous index. For 23, 875 samples were collected. 61 samples had a detect of one of the 29 PFAS, and then from there, 45 had a detect of one of the 6 regulated PFAS. And then from those 45, 23 of those exceeded the MCL or the hazardous index. All right, so just kind of want to give you a brief timeline of the PFAS rule and how it came to be before we jumped into that. So, like I said, UCMR 3 had those 6 PFAS compounds. That was published in May of 2012. And then December of 2021, UCMR 5 was published. That's the sampling that's ongoing from the EPA and includes the 29 PFAS compounds. In March of 23, the proposed PFAS rule was published in the Federal Register. And then April 10th of this year, the final PFAS rule was announced. And then in late April, the final rule was published in the Federal Register. All right, so let's go over the rule. So National Primary Drinking Water Regulation, a NPDWR establishes enforceable standards such as maximum contaminant levels, which apply to public water systems. EPA promulgates a NPDWR if agency determines after public comment that a contaminant may have adverse health effects, occurs or is likely to occur in public water systems frequently enough at levels of concern, and there's a meaningful opportunity for health risk reduction for persons served by the public water system by implementing that rule. So an overview of the rule, of the PFAS rule. So this applies to community and non-transient, non-community water systems. There is a maximum contaminant level goal and a maximum contaminant level. The maximum contaminant level goal is not the enforceable level. That's just the goal that is established. The maximum contaminant level is the enforceable level. So those are established for 6 PFAS. They are PFOA, PFOS, PFHXS, PFNA, and HFPODA or Gen X. Those each have a individual MCL. For PFHS, PFNA, Gen X, and now including a PFBS, that is included as a PFAS mixture. So that's regulated as a hazardous index that we'll go over in the next couple slides. But PWS requirements based on the rule, monitoring and reporting must be done, public notification must be done, and then reduced levels of exceeding standards. So for the MCL and MCLG, you can see that PFOA and PFOS, so for those, the MCLG is 0, and then the set MCL for those is 4 parts per trillion, or nanograms per liter. So yeah, that's PFOA and PFOS. For PFHXS, PFNA, and the Gen X chemicals, the goal is at 10 parts per trillion, and then the enforceable MCL is at 10 parts per trillion as well. And then lastly, for that hazardous index mixture, that of PFHS, PFNA, GenX, and PFBS, that MCLG is at a 1, and then the MCL is at a 1. I'm going to go over the hazardous index a little bit more in depth. So PWS monitors for the 4 compounds and then puts their results in a formula that's based on the health-based water concentration, and that's the level at which no health effects are expected for that PFAS. So just before you see the equation, I wanted to show you how they got to the numbers in the equation. So for PFHS, it's 10, as well as GenX and PFNA. Those are all 10. And then for PFBS, it's 2,000 parts per trillion. So looking at the hazardous index here, the hazardous index MCL applies to any mixture containing 2 or more of PFNA, PFHS, PFBS, and GenX. So you have to have 2 or more of these mixture here to do the equation, and then have that MCL. So if a mixture contains PFAS at levels which result in a hazardous index greater than 1, it would be in exceedance of the MCL. Compliance with the MCL is, if you're on quarterly, it would be determined by a running annual average. So each quarter you would add that up and then base it off a running annual average. And just so for example, if I had a PFBS and then a detection of a PFNA, I would have to put those 2 in there and then see what the hazardous index would be. If I only had a detection of PFNA, then that equation wouldn't be done. It just has to be 2 or more. And this equation would be done by TCQ doing compliance procedures. I just wanted y'all to see it to, if you wanted to check what we had or, just to get ahead of it to look at it. But yeah, that equation would be automatically done by TCQ through our compliance process. All right, so initial monitoring requirements. So for groundwater systems with a population under 10,000, 2 samples would be required per year at each entry point to the distribution system. And for those 2 samples, they would need to be collected within 5 to 7 months apart to meet the initial monitoring requirements. So 2 samples per year for each entry point for groundwater systems under 10,000, and those samples have to be 5 to 7 months apart. For groundwater with a population greater than or equal to 10,000, that would be quarterly sampling would be required. So 4 samples per year at each entry point to the distribution system, and those would have to be collected at least 2 to 4 months apart. For surface water or groundwater influence, this is for all surface water, groundwater, and under the influence of surface water systems, it would be 4 samples per year, so at each entry point to the distribution system, so it'd be quarterly there as well. And those samples would have to be collected 2 to 4 months apart. So after initial monitoring is done, there is a chance for reduced monitoring. So if the initial monitoring results are below the rule trigger level, which is 1/2 of the MCLs, you'd be eligible for reduced monitoring. So the rule trigger level, which is 1/2 the MCL, so it's 2 parts per trillion for PFOA or PFOS, and then 5 parts per trillion for PFHS, PFNA, and GenX, and then for hazardous index it'd be 0.5. And that is entry point specific. If you're eligible for that reduced monitoring based on the rule trigger level, all water systems would be eligible for reduced monitoring. If they meet that rule trigger level, then eligible for reduced monitoring, and that reduced monitoring is 1 sample every 3 years per entry point. If the samples from the initial monitoring are greater than or equal to the rule trigger level, which is 1/2 of the MCL, then quarterly monitoring would have to be done for that. And then when the MCL regulation begins, which I'll talk about in a little bit, a violation could be given if the run annual average of at each entry point, its entry point determined is greater than the MCL. So once MCL regulation is started, which would be in 2029, then if the running average is greater than the MCL, then you would be subject for an MCL violation. There is some opportunity for reduced monitoring after if you've had an exceedance. So for that, if after 4 consecutive quarterly sampling results, if they're below the MCLs, then that can go to annual monitoring. So 4 consecutive quarters below the MCL, then annual monitoring is allowed. And then after 3 consecutive annual samples, if they're below the rule trigger levels, which is 1/2 of the MCL, then that can be reduced to 1 sample every 3 years. So for the public notification requirements, for the if an MCL is given, once that's regulated, you have to do the notice as soon as possible, but within 30 days of violation. If there's a M&R violation, then notice monitoring and reporting violation, then notice would have to be given no later than 1 year after the system learns of the violation. And then for the CCR, if there are detections, then you would have to have those levels of PFAS in your CCR along with health effects language. And as always, for the tier 3s, they could be included in the CCR. So important dates for PFAS. So within 3 years, so by 2027, that initial monitoring must be completed. EPA has said you can use the data from UCMR5 to meet those initial requirements, and then if you're not part of UCMR5, then TCQ will do your initial monitoring sampling for you if you're not part of UCMR5. And that will be, so the initial monitoring must be done by 2027, and then starting in 2027, the compliance monitoring would begin. So that's when you would do the exceedance monitoring quarterly, or if you're eligible for reduced, then that 1 sample every 3 years. So that compliance monitoring would be done starting 2027. Starting then, you would have to that monitoring and reporting would be in effect. So if you miss a sample, then a monitoring and reporting violation could be given. And then if there's detections, must include it in the CCR. And then so starting in 2029, that's when the MCL compliance would begin. So that's when the maximum contaminant level rule would go into effect. So there is, if you have detections, there is a few years to, start that treatment and, get those levels down before the maximum contaminant level regulation comes into effect in 2029. And then obviously if you get a MCL violation, then you would be required to do that public notice for those MCLs. Just going to go over a brief overview of treatment options. If you're interested in a more in-depth overview of the PFAS treatment options, there is a presentation at 1:45 tomorrow in this room that will go more into depth over the PFAS treatment options. But just a brief overview of this. So this is what the EPA is proposing as the best available treatments. So there is granular activated carbon. And the pros of that, it's better at removing long-chain PFAS. Long-chain PFAS is PFOS, PFOA, and PFNA. It's less energy intensive than RO, and then media may be replaced. The cons of it would be less effective for short-chain PFAS, and short-chain PFAS is PFBS, PFHXS, and HFPODA, or those Gen X chemicals. Less effective at short-chain PFAS. Pressure vessel or independent treatment unit must be added, and then the media disposal may be an issue. For anion exchange, it would be The pros of it is it's short-chain PFAS are more likely to be removed. The cons of it would be disposal of the resin could be an issue. And then for nanofiltration or reverse osmosis, it's effective in removing long and short chains PFAS, but the cons of it would be it's energy intensive and costly, and then disposal of waste may add to cost. Just wanted to share the FMT program's contact information. They're starting to put together, as we learn more about PFAS, starting to put together PFAS classes. So if you reach out to them, you can get put on a list to reach out when we can help with PFAS through FMT. And then here's my contact information. There's my direct email, and then also a PFAS inbox that we have. Yeah, thank you all. And then we have time for questions as well if y'all have any questions for me.
All right, you said all these are mostly they're all man-made compounds, correct?
Right.
All right. So drinking water, I deal with surface water. So are these contaminants that, because I don't understand your full chain of alphabet soup there.
Right, yeah.
We primarily treat with a set of 4 chemicals there, usually caustic soda, liquid ammonium sulfate, sodium hypochlorite, and aluminum chlorohydrate, which is our flocculant. Are these things that would contain these, or is it something that just naturally washed into the lake, now it's my problem?
So yeah, it would just be those those man-made ones.
So we're now on the hook for runoff from something else.
Yeah, unfortunately, that would, based on the regulations.
So if I have a cattle farmer that fertilizes and does all kinds of other things on his property, and it happens to wash into my lake, it's now my problem, and I have to figure out how to fix him on his property.
Yeah, based on the regulations, it would be, you have to treat the water that's being provided to the customers.
To answer that question, there are lawsuits that we're aware of happening that are trying to address, fixing it at the source, so it's not a water systems problem. So we'll have to stay tuned and keep following those.
The cost of this could get astronomical, in that, and a lot of these things. I mean, to be able to understand what the toxic ones are, because you don't. This is, I'm nothing against you, but it is slightly less than informative on what to look for as far as the 29 indicators or that they tested for, and what the toxic ones are, what the toxic ones aren't, and where you would find them, and what actually contributes to these 29 factors that they randomly went and generated.
Yeah, there's still a lot where we're trying to process and digest, just like y'all. But yeah, we are aware that.
It's vague at best.
Yeah.
So
it's a lot. We are working towards providing better guidance, but yeah.
At the last WOG meeting, there was a discussion about certifying systems to self-sample for PFAS given the low concentration. Do you guys have any update on that?
There's no update on the, system sampling themselves. We've had internal talks about that, but no update on that.
With public water systems already treating for PFAS, with membrane filters and whatnot, how are these water systems disposing of that filtrate that they're, generating? Because, you're just putting it back in the environment if you're just dumping it somewhere. So I'm just curious how that's happening.
I'm not sure on the waste side of things, unfortunately. But if you send me an email, I could try to get some more information and connect you with our waste folks that could answer that question better than me.
Yes, the MCLs are in the part per trillion. I'm wondering why the MCLs are so low.
Yeah, that's what the EPA set it at. Just because they're such with the health effects, it can, those small it can be, the very small, parts per trillion can show health effects. So that's why they decided to regulate it at that, if that answers your question.
Is that also in conjunction with reducing the manufacturing of the substances since it's man-made?
Yeah, I know, I'm not sure on the, what the talks are with, preventing the creating of them and things like that and use of them.
So just so I understand, we could be treating to remove, but also increasing the levels at the same time? Yes, in theory, as the water system, we could be treating to remove the levels of the PFAS to be in compliance, while at the same time, perhaps our source water could be increasing whatever is causing it to be in there in the first place.
Yes, you are correct that you don't have control over, the non-point source pollution of your source water because that's, runoff and things like that are out of control. So, yes, we are working towards providing some guidance to kind of address those concerns.
We got next question right here.
Is the state looking at giving water systems the flexibility to use an accredited lab for the PFAS testing like they do with lead and copper, or is it just going to stick solely with the contract lab with the state?
We're in talks about maybe changing that process, but right now, Laura, it looks like you want to chime in on this one.
I will say no matter what, the analysis will be performed by an accredited laboratory. So what we're doing right now is working with our lab accreditation group to work towards getting fields provided. There's currently no fields of accreditation available in Texas, so that's the first step, is to being able to have labs do the analysis for PFAS. So more to come on that, but no matter what, an accredited lab will have to do it.
If we choose to do voluntary PFAS monitoring, can we use that as our initial year of monitoring, if it's for consecutive quarters?
So if I understand you right, you're asking about if you do voluntary sampling yourself, can you use that for initial monitoring?
Yes.
Unfortunately, no. It would have to be through TCQ's monitoring or UCMR 5.
Okay. So if I've got some potential outliers in the UCMR5 results that I've gotten already, and I'm doing voluntary just to kind of keep an eye on everything, and it seems like it's maybe a fluke, is there any way that I'm not going to have to do frequent monitoring to start out when it becomes a compliance thing in 27?
Yeah, if you, we can have discussions about that. If you have, questions about the, were you asking if to make sure that the USMR 5 data is correct to do your own sampling and compare? Is that what you're asking?
Yeah, so I've done some voluntary sampling already with the same method, same lab, the 533 method, and I'm not finding anything in it where all my UCMR5 samples came back with the same 4 compounds each time.
Yeah, I know, you're probably not the only one, maybe even within this room, but a lot of folks are talking about doing their own process sampling just to keep track of their own data, right? I will say that, so we're also working internally to update our quality assurance project plan for PFAS. So, we're taking in the feedback that we're getting from folks, but any sampling will have to be done in accordance with our QAPP. So as long as the sampling is in accordance with that, then that's what we're going to use for our compliance. So of course, folks are welcome to do additional monitoring, voluntary monitoring for their own, process purposes, but for us to run compliance, it's going to be sampling that's done in accordance with our QAP.
Okay, so the voluntary sampling that I've been doing would not qualify under that?
Not until we revise our QAP.
Okay.
So not at this time.
Okay, thank you.